2.7 absolute value functions and graphs. So we have to know what absolute value means. Absolute value is this right here. This is the function. That means that x, no matter what x is, it's always going to be positive because it's distance away from 0. Now when we draw this graph, it's going to become a V shape. So there is a vertical line right down the middle called the axis symmetry, meaning it's the exact same on both sides. So if we just look at my parent function, so this right here is my parent function because there's no other numbers with this. Now first we're going to make a table. So on this table, I'm going to put 0 in the middle, and I'm going to evaluate 1, 2, 3, that's a 3, -1, -2, -3. So what I'm going to be doing right now, if I plug 3 into this equation, the absolute value of 3 is 3. If I plug 2 into my equation, the absolute value of 2 is 2. Absolute value of 1 is 1, absolute value of 0, 0. If I plug -1 into my equation, the absolute value of -1 is 1. Absolute value of -2 is 2, and absolute value of -3 is 3. So if I plot those points first, this is what my parent function looks like. Again, if I don't have anything added or subtracted here. My function is pointing up. My vertex is where it starts, the V, so that point for my parent function would be 0, 0. When I look at my axis symmetry, it's an invisible line. You don't have to write this in, but it's an invisible line that goes through the vertex, meaning it's the exact sum on both sides. That line is equal to x equals 0. I look at my vertex to decide if it's a max or min. In this case, this is my smallest point will ever be, so it's going to be a minimum. And there's no transformation in words because there's no numbers with it. But let's actually get into what if we do have numbers? What do they represent? So in this larger equation, kind of go over what this is all saying. This a value, if I have this a value, that means if it's a positive, it's going to stay pointing up. If it's a negative, that a is negative, it's going to reflect, so it's going to flip it or reflect it down, pointing down. This a right here, if this is going to be larger, so if a, the absolute value, so it doesn't matter with the negative is going to be reflect or not. If this a is greater than 1, it's going to be a vertical stretch. Vertical stretch it out. If that a is less than 1, the absolute value of it, it's going to be a vertical compression. Vertical compress. And I'll go over this again tomorrow. But when I'm looking inside the equation, inside anything inside the absolute value, that would be your h, this is going to move it left or right. It's always opposite. So if it says positive, if this is x plus 1, it's actually going to the left. And this k right here, the k on the outside is going to move it up or down. So now if I just look at my equations down below, I can tell what the transformation is. I'm going to do these first two, and then you're going to do the next two by yourself. So if I look at these two, I do not see a negative sign, so I'm not going to write anything but reflect. However, I see this 2 right here. That's going to be a vertical stretch of 2. I see my 1. That's going to be equal to my h. Since it's a negative, so if I look back at this original, this says a negative right here. So with a negative, that means it's actually moving to the right. So whenever you see a negative, it's moving to the right. So my 1, my h is going to move to the right 1. And I see a 3. That's my k, and it's positive. So if it's positive, it's going to move up 3. So I have 3 different transformations. My next one, I have this negative right here. So -1, that's my a. That will be a reflect. Reflection. And I have this -1 outside of the absolute value, so that's going to move it down 1. So I want you to do the next two by yourself. So now I'm going to actually graph it. So I can actually know what my vertex is without actually doing anything else. So my vertex will be my h, k. In this case, remember, a subtraction means positive. So my vertex is going to be 1, 3 for this first one. My axis of symmetry would be x equals 1 because it's always based off of your x value. This will be a minimum because I'm not reflecting it. So my transformation in words, again, if I look at this, the 2 is going to be a vertical stretch of 2. I'm going to be moving to the right 1, and I'm going to be moving up 3. So when I'm graphing this, I'm going to 1. I'm going to actually try to zoom in so I can see it better. go to 1, 3, and then you can plug in the points to the left and right. And I'm actually going to be showing this in your calculator too so that you can make sure to find your table. Or else you can just plug in, if I plug -1 into my equation, what would I get? I would get a positive 5. If I plug 2 into my equation, I would get a positive 5. You should have 5 points when graphing this. Or the 2 out in front is actually your slope too, if you notice. So this is what my first graph will look like. I just want you to try B by yourself. We're going to go through C and D in class. And now when I'm actually writing the equation, so the first thing you want to figure out is your vertex. So my vertex right here is a positive 2, 1, 2, 3, 4. Positive 2 and a positive 4. Then you're only going to be looking, so here's your axis of symmetry, you're only going to be looking at the right and you're looking for your slope. So here's another point on the right. So from my vertex, I'm going to go up 2, so a positive 2, into the right 3. So then my A value will be 2/3. How do you know if it was a negative? Well, if I just kind of look at this next one, I would have gone down, so that'd be a negative, and then to the right, because it's always looking to the right-hand side. So when I'm writing this, y will be equal to my A is 2/3. Absolute value, my x is always opposite, so it's going to be subtract 2, and then up 4. So I want you to try your very hardest to do B and C by yourself, and then you have a great day. Great, grand, wonderful day, to be more precise.